Welcome back. Today we're going to be talking about how relations can be organized, formalized, how we can kind of think about them and evaluate them. To start with, here's some definitions we need to know. Probably definitions or words you've heard before, but you have to have some meaning and understand what they are. To start with, domain, all input values of a relation. They're your x values. It's what we put into our function. The range, all the output values are the y values. Everything that comes out, our finished product. Function, a relation in which there is exactly one output for each input value. So think about this one. Copy these definitions down and have them in your notes. Now, one way we can organize our relations is with a mapping. This is what a mapping looks like. We're going to look at three of them. To start with, we have this one in blue and this one in red. What we start with over here could be categorized with our domain. What we end with is our range. So if you notice, there's an arrow starting from the 1 going to 5. There's an arrow going from starting at 2, pointing to 8, and one going from 3 going to 11. So our domain numbers, if we wanted to explain these, would be 1, 2, and 3. Our range would be 5, 8, and 11. So we want to be able to identify what our domain and range are, what we start with and what we finish with. We can express these also as an ordered pair. Here we express this as a mapping. As an ordered pair, we can express this as 1, 5, 2, 8, and 3, 11. Now, the last thing about this that we're going to talk about is this a function? So looking at this mapping, looking at these ordered pairs, we could also express this as a table, I should say. 1, 2, 3, and it goes to 5, 8, 11. You can see that these numbers are also kind of paired up in a table, in a mapping, and as an ordered pair. Now, is this a function? Let's go back. Does each input have exactly one output? I see that there's one arrow coming from each of these. I see that these numbers are not repeating the x values. So yes, this is a function. You have to identify if these are functions or not. Now let's look at this red one. So think about what your domain is. Again, we have this arrow of 3 going to 20, 4 going to 10, 5 going to 20, and 6 going to 10. So again, our domain would be 3, 4, 5, and 6. Not too much calculation going on. Just have to understand and evaluate what each of them is. Our range would be just 10 and 20. There's two numbers for our range in this one. Okay. So if we want to express this now as ordered pairs, again, we start with 3, we go to 20. 4 and 10. 5 and 20. And then 6 and 10. Usually the numbers go in order. That's why the arrows are kind of crossing. Make this as a table. 3, 20, 4, 10, 5, 20, 6, 10. There's our XY chart. Now we have to ask ourselves, is this a function? Does each input have only one output? Is there only one output for each input? I see one arrow coming from 3, one arrow coming from 4, one arrow coming from 5, one arrow coming from 6. Yeah, there's only one output for each input. I only see my x values here once. As an ordered pair, I only see the x values once. So this, again, is a function. The last one we're going to look at is here in green. So our domain. Put it over here so we can see it. Domain, -2, 0, and 3. Our range, -3, -1, 1, and 3. Write these as ordered pairs. You have -2, -3. You can't see that. I'm going to erase this one over here so you can see this a little bit better. So we have -2, -3. We have -2, +3. 0, -1, and 3, +1. And represent this as a table. You have x and y. -2, 0, and 3. -3, -1, 1, and 3. So here we have these values. Now, is this a function? Well, -2, this input has two outputs. It goes to -3 and +3. In our chart, it's listed 2 times with 2 different outputs. As an ordered pair, we're writing the -2 as our x twice. Therefore, this is not a function. Doesn't work. So the difference between the two is, again, if the x's are repeated or have 2 arrows coming from them, not a function. If there's just one, it is a function. See you next time.